Alrighty guys, we are back on page 16. This time we'll be going through questions 15 through 18. These are some more involved questions, so these might take a little longer. Hopefully I don't have any trouble with the video uploading, but we shall see. So all of the questions 15 through 18 are going to be corresponding to a distribution where the mean is 50. The mean is 50 and the standard deviation is 5. So the first question here asks about the raw score, which would be the x value, that corresponds with the 14th percentile. So let's talk percentile for a minute. Do you guys remember what percentile means? So the percentile, let's say I am at the 90th percentile. You get an ACT score or something back, and it says you're at the 90th percentile. When you get this back, you're going to feel great because that means that you scored at or above 90% of people. That's great, right? Now the 14th percentile, that's not looking as hot. That means you scored at or above 14% of people. So that's really on the lower end. So when we think of our distribution, I'm going to cut it down the middle here. That's the mean is 50. Now, this is where, even though no matter what the mean was, I know it's kind of confusing because the mean is 50 in this problem, so I don't want that to confuse you, but for any problem, the mean is going to be the 50th percentile. Whether the mean was 50, whether it was 100, whether it was 6,000, the mean is always going to be the 50th percentile. So we can imagine if this is the 50th percentile, the 14th percentile is probably going to be like way over here, right? Now, what's something I always tell you guys? Area equals percent. So we've got 14% of people at the 14th percentile here. So, guess what that means? That means we are going to be looking for the spot where we're going to be looking for this spot here, and that's going to be where there is 0.14 in the tail. So like we said, area equals percent. And the 14th percentile is where you're at or above 14% of people. So I'm going to go over here to my z-table. We're going to be looking in the smaller portion because, sorry, ignore this from a previous problem. We're going to be looking at the smaller portion because we are looking in the tail, and we are going to find where there is 0.14 in the tail. So I'm just going to go ahead and search for that here. Sorry. Okay. Here we go. Here's where there's 0.14 in the tail, and it looks like that's going to be a z-score of 1.08. And because we are on the left side here, the z is always going to be negative. So it's going to be, oh, I forget my number already. What did I say? 1.08. So the z-score is negative 1.08 that corresponds with the 14th percentile, but remember that it's asking not for the z-score, but instead for the raw score. So we're going to have to use our formula sheet to convert z of negative 1.08 into a raw score or an x value. So just going to go up here to my formula sheet because we have the z-score, we're looking for the raw score. So our formula is going to be, x equals mu plus z times the standard deviation. Lucky for us, we are already given this information up here. So we're going to do x equals 50 plus our z-score here, negative 1.08, times the standard deviation, which we were given up top, which is 5. I'm going to go ahead and plug this into my calculator, starting out with negative 1.08 times 5. So that gives us negative 5.4. So we're doing 50 minus 5.4. So 50 minus 5.4 is 44.6. So the score that corresponds with the 14th percentile is 44.6. So that is going to be your answer to question number 15 on page 16 of the homework packet. So let's go ahead and move on to question number 16. So question number 16 says, which z-score cuts off the top 10% of the distribution? So this brings us back again to our talk about percentiles. If you are at the top 10% of the distribution, that means you are at the 90th percentile. You scored better than 90% of people, right? So we'll say this is the 90%. This is where you are over here. You're doing great. You're at the top 10%. So how are we going to figure out what z-score cuts off the top 10% of the distribution? So, like we always say, area equals percentage. We are looking for where there is 90% in the body or where there is 10% in the tail. Now, it's up to you which one you want to use. It's going to be the same either way, which hopefully that doesn't confuse you. But I am going to look for where there is 90% in the body because we're at the 90th percentile, and that's the easiest way for me to visualize that. So area equals percentage. If it's 90%, we are going to move that decimal point over 2 places, and we're going to look for 0.90 in the body. Likewise, if you wanted to do it with the 10%, since that's the number that's actually in the question, that's fine. You'll get the same answer. You would just do 10%, move that decimal place over 2 spaces. You would get 0.10, and this one would be in the tail. Since it's the smaller section here of the distribution, that would be in the tail, but 90% is in the body. So I'm going to jump over here to my formula sheet, go down to this here, and I'm looking for where there is 0.9 in the larger portion, and I'm going to find the z-score that is associated with that. So I'm just searching here for 0.9 in the larger portion or in the body. So it looks like it's going to be right here. Z equals 1.29. Let's see if that... Now, this is super close. So you could also say 1.28. You see how 1.28, that has 0.8997 in the body? And this one here, 1.29, has 0.9015 in the body. This is going to be super duper similar. I doubt that a professor would mark you off for putting one instead of the other, but we'll just go ahead and put Z equals 1.28. That is the z-score that cuts off the top 10% of the distribution. Now, I will show you what I'm talking about with the 10% by finding the same score with the 10%. So we're looking where it would be 0.10 in the smaller portion. So let's see here. Where would we find 0.10? Alrighty, look right there. 0.1003 in the smaller portion. It's the same exact z-score, 1.28. So like I said, you can do it either way, whichever one works best for you and which helps you understand it best. But no matter what you do, the z-score is going to be 1.28 that cuts off the top 10% of the distribution. And the other way that you can think of that is the z-score that corresponds with the 90th percentile. That's where you're scoring above or at 90% of the population, is Z equals 1.28. And like I said, if you got 1.29, that's fine too. It's pretty darn similar. So that is question 16. Let's move on to question number 17. This one says, what raw score cuts off the top 10% of this distribution? Well, this one's super easy given that we just found the z-score for the top 10%. So all we're going to do is take this here from the question before, the 1.28, and we're going to plug that in to our conversion formula here. We're going to plug that into here so we can find the raw score that's associated with that z-score. So raw score is x equals mu plus z times the standard deviation. For this distribution, remember here we said that our mean or our mu was 50 and our standard deviation was 5. So x equals 50 plus our z that we determined was 1.28 times 5. I'm going to go ahead and plug that into my calculator, starting with 1.28 times 5. That gave me 6.4. So now I'm just going to do 6.4 plus 50, which gives you 56.4. So the answer for number 17 is 56.4. That is the raw score that cuts off the top 10% of the distribution. So last one here is number 18. It's asking for the raw scores that mark off the middle 60%. These ones can take a little more brain power, a little more critical thinking, all that good stuff, because it's asking for the middle 60%. So let's think of it this way. We know that the whole entire graph is going to be 100%, right? They all are. We're looking for the middle 60%, so I'm just going to subtract 60% from 100%, and I'm going to get 40%, right? Because 40 plus 60 equals 100. So I know I'm looking for the 60%, which is not the 40%. Now, since it's in the middle, we're going to have to divide this 40% in 2, which is going to give us 20%. I hope this makes sense. Sometimes it can be a little hard to visualize, but what I'm saying is we're going to have to cut out the top 20% and the bottom 20% in order to find the middle 60% here. And that's probably way more than 60%. I did not draw that to scale, so let me just redraw that here. Okay, that gives you a little bit better. Oop, I'm not even going to do that. So anyway, we're looking for the middle part. We know that 40% divided by 2 would be 20. We're looking at 20% on each side. So what we're going to do is we are going to find first the z-score that corresponds with the 20th percentile. So remember, the 20th percentile is where you score at or above 20% of people. Area, like always, equals percentage. I'm going to move that decimal place over 2. So it's 0.20 in the tail. Same way on this side, 0.20 in the tail. Remember that because these are symmetrical, this is just going to be the same z-score on both sides, except the one on the left here will be negative. So I'm going to jump over to my z table here, and I'm looking for in the tail where it says 0.2. So let's see where that would be. Okay, so it looks like that's going to be right here, 0.2. Oh, just kidding. Don't do that. You've got to be really precise with it because I almost said something that wasn't true. Okay, so it's going to be between these two values, between 0.84 and 0.85. Because these ones are the closest to 0.2, and 0.85 is a little bit closer. I know it looks weird that it's 0.1977, but that's only 3 away from 0.2, and this one's 5 away from 0.2, so we're going to go with the 0.85. So z equals z equals positive 0.85 and z equals negative 0.85. Now remember that we are looking for the raw score. Right now we've only found the z-score, so we have to go back to our formula sheet and find the raw score that corresponds to z equals negative 0.85 and z equals positive 0.85. So I'll bring you back over to our formula sheet again. We are looking for the raw score, so we're going to use this formula here. So x equals the mean plus z times the standard deviation. If you remember, our mean is 50. I'll go ahead and point that out for you just so you remember. The mean we were given is 50. The standard deviation we were given is 5. So I'm not making those numbers up. I'm just pulling them right from the formula. Or I'm sorry, right from the question. So x equals 50 plus negative 0.85 times 5. And then x equals 50 plus positive 0.85 times 5. I'm going to go ahead and plug that into my calculator here, starting with negative 0.85 times 5. That gave me negative 4.25, 50 on this side over here, and 0.85 times 5 is positive 4.25. So then we're just going to round these out. 50 minus 4.25 is 45.75, and 50 plus 4.25 is 54.25. So the numbers that mark off the middle 60% of the distribution are going to be 45.75 and 54.25. So I'm just going to go back up here and remind you. You know what, I'll actually redraw it just so it's super clear. Here is our distribution, which is, as always, a hot mess, because I'm not so good at drawing those. Sorry about that again. We know, oh my goodness, it's just getting worse, people. At some point, something's got to give, right? Okay, good enough. You guys know what I mean. We were given, right down the middle here, our mean is 50. Our standard deviation is 5. It's asking us for the middle 60%. Let's estimate that 60% is like this. So if this here is our 60%, we're trying to find the points here and here to mark that off. And we did that by saying, okay, if this is 60%, then that means that 20% of the distribution will be on this side, the other 20% is going to be on this side. And when we plugged that into our formulas, we found 45.75 was over here, and 54.25 was over on this side. So those mark off the middle 60%. And always keep in mind that the way that we found the z-scores that correspond to the raw scores was by looking where there is 0.20 in the tail. That gave us our z-score. We then plugged the answer for the z-score, which was negative and positive 0.85. We plugged that into our formula to find the raw scores that we have here of 45.75 and 54.25. I hope this helped. I know these questions were a little bit more involved than some of the other ones we have gone over so far, but I will be uploading this. Hopefully it uploads fine, and if you have any questions, just let me know. Thank you guys.